Here's the equation again. Negative 4 is equal to y subtract 9. We can simply pick up the right-hand side and the left-hand side and swap. Swapping those gives us y subtract 9 equals negative 4. This means that we have the variable on the left-hand side now. The equation is unchanged. We've simply swapped sides. We then can use the fact that subtract 9 means add negative 9, and that gives us the reason to add 9 to both sides. The 9's now cancel on the left-hand side, and we get y equals 5, the same thing we had before. It's just that the y's on the left and the numbers on the right. Anytime you wish, you may pick up the two sides of an equation and just swap them. Copy exactly as they are. Just swap sides. Let me give you some exercises now. You're to solve each equation. Your two equations are m subtract 10 equals 7 and 9 equals negative 9 add p. Copy these. When you get them copied, stop the tape, work the problems, and then turn the tape back on to check your answers. Here your answers are. M is equal to 17. P is equal to 18. If you missed either of them, be sure to mark that on your paper. Try to check it yourself. If you cannot find your mistakes, be sure to ask for help. Now we have our second rule for working with equations, for manipulating equations. The multiplication property of equations. It says, multiplying the same non-zero expression by both sides of an equation does not change its solution. Multiplying the same non-zero expression by both sides of an equation does not change its solution. We have a word in this one that we didn't have in the addition property. The word is non-zero. Why do we have non-zero there? Well, if we have the equation A equals B, and then we multiply both sides of the equation by 0, what answers do we get? Well, 0 times A is 0, 0 times B is 0. We get 0 equals 0, which is certainly true, but did we get the solution to the original equation? We don't know what the original equation would have been. We don't know what its solution is, but we don't even have a variable left. All we've got is a couple of zeros. That doesn't tell us anything. So if you multiply both sides by 0, you certainly change the solution. We wiped it out. It's gone. So we must be careful in multiplying never to choose to multiply by 0. The multiplication property of equations has more uses than the others that we've looked at. Let's look at the uses for the multiplication property. Our first is remove fractions by multiplying both sides by the least common denominator of all the fractions. Remove fractions by multiplying both sides of the equation by the least common denominator of all the fractions. We will come back to this rule on a later lesson. We will come back to using it in this way later on. But this is a major use of the multiplication property. Our second use is to remove a coefficient by multiplying both sides by its reciprocal. Remove a coefficient by multiplying both sides of the equation by the reciprocal of the coefficient. This one we will use very shortly. Multiplying by the reciprocal of a coefficient will remove a coefficient. Our third use is to remove a coefficient by dividing both sides by the coefficient. Multiplying by a reciprocal is accomplished also by dividing by the same number, not by the reciprocal, but by the original number. So our multiplication property will be used on the remaining part of this lesson in these two ways to remove a coefficient. Let's look at some examples. We're to solve each of the following equations. Our first one is x over 3 equals negative 5. X over 3 equals negative 5. Notice that x is over 3. Over means divided by. Well, the reverse of dividing is multiplying. We want to remove this divisor 3. To do so, we will multiply both sides of the equation by 3. Multiply both sides of the equation by 3. 3 times the left-hand side equals 3 times the right-hand side. On the left-hand side, we have 3 times that fraction. We can write 3 over 1 if we like. The 3's can be canceled, so that we get 1x over 1, which is just x. On the right-hand side, we get negative 15. So x equals negative 15. We have variable equals constant, the solution form. So all that's left is to check it. For the check, our equation is x over 3 is equal to negative 5. We copy the equation, draw the horizontal line below it. On the right-hand side of this one, we're going to have negative 5. On the left-hand side, we have a set of parentheses for the x. The x is representing negative 15. So let's fill in negative 15. Then on the left, negative 15 divided by 3 gives us negative 5. Negative 5 equals negative 5, which checks. That means the solution x equals negative 15 is correct. So in this case, we eliminated the coefficient by multiplying. The next example, negative 4/5 x is equal to 10. Negative 4/5 x is equal to 10. Notice that the negative 4/5 beside the x means multiplying. We want to eliminate that multiplied coefficient. We'll multiply by the reciprocal. The reciprocal of negative 4/5 is negative 5/4. So let's multiply both sides by negative 5/4. Now, the negative on the original fraction was with the numerator 4. When we turn this upside down, we can keep the negative with the numerator if we wish, or we can let it float up to the top and put it with the numerator of the reciprocal. My personal preference is to keep the minus sign with the numerator always so it never gets overlooked. So that's what I've done here. If you feel better putting the negative with the 4 instead of with the 5, that's perfectly correct. It's just an alternate form. Well, we've got fractions, so let's do our favorite thing with multiplying fractions, which is canceling. Let's cancel these. The 4 gives us 1, 4 into negative 4 gives us negative 1. 5 into 5 gives us 1, 5 into negative 5 gives us negative 1. On the right-hand side, let's put 1 below the 10 so that we can cancel there. 2 goes into 4 2 times. 2 goes into 10 5 times. Now on the left we have negative 1 times negative 1, which is positive 1, x, over positive 1, Well, 1x over 1 is just plain x. On the right-hand side, we get negative 25 over 2.